Thank you. Hi, everyone. So I'm Robin. I work on our internal platform as a service, which we call Micros. And the aim of Micros is to enable engineers within Atlassian to develop and operate microservices quickly and easily. So these concepts of microservices, service decomposition, DevOps, these are all concepts that are very closely related to Atlassian Connect, which, as you know, is about running, developing, and operating your own services. So what I'd like to do is to give some insight into our platform, how it works, and some of the lessons we've learned along the way, in the hopes that there'll be some takeaways for you when you think about running your own services, whether that involves assessing third-party hosted PaaSes like Heroku, AWS Elastic Beanstalk, or looking at lower-level components like Mesosphere, Kubernetes, or even building your own platform components. So I'll talk about why we have a platform in the first place. I'll talk about how it works and the lessons learned. But before we do that, let me give you a really high-level overview of what the platform actually is. So what we provide Atlassian developers is a number of tools and services and an execution environment that allows developers to have their code up and running and available to the wider world in a few minutes. And because these teams that build these services are also responsible for operating them, we feed back a bunch of information to them in the form of monitoring and logging so that they can manage their service effectively. And the platform also encourages, and in some cases even enforces some architectural best practices so that the services can be as healthy as they can be. So we haven't invented much here. If you peel off the lid and have a look under the covers, we're really just gluing together a number of third-party hosted components, primarily AWS services, and also a number of open source components like Elasticsearch and Docker. So the platform went live a couple of years ago, and right now we have well over 400 services running on top of it. And these are services built by Atlassians for all sorts of purposes, ranging from experiments to try out new technologies and new ideas, to ship it projects, to internal tooling like wallboards and chatbots, to Connect add-ons, so we've got both internal Connect add-ons and public Connect add-ons running on the platform, all the way to core components of our critical customer-facing products. So for example, a lot of Bitbucket pipelines runs on this platform. Various parts of Confluence collaborative editing runs on there as well. So the question is, how did we get to this point? How did we get to the point where we have so many services that we need an underlying platform to manage them all? And to understand that, I'd like to take a look at how service decomposition has evolved within Atlassian. And we'll start by looking at how JIRA and Confluence Cloud work today. So when you go and sign up for JIRA or Confluence Cloud today, what's actually happening under the covers is we're provisioning a Linux container for every customer that signs up. So when you get your something.atlassian.net address, you're actually under the covers getting a Linux container. And within that container, we run the full JIRA and Confluence, or whatever products have been bought, we run the full JVM monolithic processes inside of those containers. So, and those are very similar to the processes that would run on premises if you downloaded the application. Now, there are a few drawbacks to this approach. Number one is whenever a new customer signs up, we have to allocate a full container for them, no matter how much they actually use their instance. And that takes up precious resources in our racks. Problem number two is that it couples functionality in a way that reduces agility. So for example, if we find a problem in JIRA or Confluence close to the release point, that'll block the release and it will prevent us from getting features out in an unrelated part of the product. And then lastly, it also limits technology choices because any new features or improvements have to fit within these monolithic processes. So they have to use the same JVM stack, the same libraries and frameworks, and exist within the same resource constraints, so memory and so on, as those monolithic processes. So with all that in mind, this architecture has served us very well. There's lots of racks, lots of data centers, and this has scaled us from a few thousand instances to well over 100,000 instances. So it has worked very well. But when we think about our next order of magnitude increase in user counts and also in developers contributing to the software, it becomes apparent that we need to move away from this monolithic approach. And the really interesting thing is that Connect itself was a big step in the right direction towards service decomposition. So a couple of years ago, I was at Atlas Camp talking about Who's Looking, which was one of the really early Connect add-ons. It's a very, very simple one. All it does is it shows you who else is looking at a JIRA issue when you're looking at it. And that really began as an experiment to see whether we could take a piece of functionality which, on the surface, is intimately tied to the product, but under the covers exists very independently. So with an independent deployment lifecycle, independent scalability characteristics, and isolated in such a way that if it has problems, those problems don't affect the core product, and they don't affect other add-ons that are running in a similar manner. And all that was successful, and of course, Connect has evolved since then, and you can do much, much more sophisticated things than this. So thanks to all of you who have kind of pushed the boundaries of Connect and made it what it is today. Because Connect has really solidified service decomposition as a viable architectural path for Atlassian Cloud. And so with that in mind, last year I was at Atlas Camp talking about Blob Store, which was our first example of taking not an add-on, but core functionality from JIRA Cloud and extracting that into a shared service. So in this case, it was attachment storage in JIRA. So we removed the attachment storage from the 100,000 JIRA instances in Atlassian Cloud and moved that out into a shared service in AWS, running on top of the platform that I'm talking about today. And we didn't stop there. Since then, many other bits of functionality have been extracted, ranging from attachment conversion to the shared user administration UIs. All of those have been extracted into services that run on top of the platform and benefit from those same advantages of Connect in terms of isolation and independence and agility. And this trend is going to continue. So in the not too distant future, we expect that much of the functionality that constitutes JIRA and Confluence Cloud and significant chunks of Bitbucket and HipChat Cloud will be running on this platform. So with that in mind, you can see the importance of this shared platform component. So let's peel the covers back a bit and have a look to see how it actually works and what it actually does. And let's start that by looking at it from the developer's perspective. So an Atlassian developer wants to use the platform. What do they need to do? So they need to supply two things. Firstly, a service artifact, and secondly, a service descriptor. So the artifact is a binary. It's the kind of meat of the application. It can be a jar file, an NPM module, or a Docker image. And the developer pushes those into an artifact store, like a Docker registry. And then they also need to supply a service descriptor, which is a chunk of JSON or YAML, which describes the service. So just to demystify that, and you don't need to parse the details of this, but this is what a service descriptor might look like. So it can start off very simple, with just a reference back to the artifact and a bit of naming information, but then it can evolve into containing a declarative description of the scalability characteristics, like minimum, maximum node count, the backing resources that are required by the service, like a database or a queue. All of that will be declared in the service descriptor. So once the dev has their service descriptor, they invoke the Micros tooling, passing it in, and then Micros goes and deploys their service in AWS. And we use CloudFormation for this. And the first thing we'll do is provision a compute stack, which consists of a load balancer and a bunch of EC2 instances in an auto-scaling group across availability zones. And those will suck in the service artifacts provided by the developer. And we also go and provision the backing resources, so any databases, queues, any other external resources that the service requires. So, and that's pretty much it. So once that's done, the service is available at something.atlassian.io, either internally within the Atlassian network or visible on the public internet if the developer has opted to do that. So that's the core purpose of Micros. It's pretty straightforward. Now, I mentioned logging and monitoring as being an important part of this as well, so let's take a closer look at that. So what we do from a monitoring perspective is we enable service owners to pump out service-level metrics to statsd. And then beneath that, on the node, we use collectd to capture infrastructure-level metrics, and CloudWatch to capture metrics across all of the resources that constitute the service. And all of that gets pumped into Datadog, which provides a really nice centralized place for developers to build dashboards that correlate all of this data, and they can set thresholds to be alerted on whatever anomalous behavior they may be concerned about. And then on the logging front, anything that goes out to standard error or standard out from the service, we pump through FluentD, then into a Kinesis stream, and then into an Elasticsearch cluster, which is fronted by Kibana. So again, developers can build really rich dashboards to get a lot of insight from their log data. And the team that worked on our logging infrastructure did some really awesome engineering. And we can actually process well over 4 terabytes a day of log data and get that ingested and indexed in real time, which is really, really valuable for service owners. Now, in practice, this is what deploying a service looks like. So we provide a CLI tool. So devs just type microservice deploy, their service name, a reference to their service descriptor, and then all that stuff I just talked about happens. A lot of devs like to wrap this up in their build or deploy plan. So then you get that really nice flow of just merging to master. That kicks off your build and deploy, and then your code is up and running at something.atlassian.io. Some teams even do continuous deployment, right? So every change will bubble through environments, go through appropriate testing, and end up facing the customer with no manual intervention from the service owner, which is pretty neat. And the important thing to note here is that anyone at Atlassian can do this. Anyone can go and create a new service. And in a typical week, we'll probably have 200-300 engineers interacting with the platform, deploying and managing services. So if these numbers sound very big to you, and therefore the concept of a platform as a service feels very heavyweight to you, the rule of thumb that I'd suggest is you'd probably want in the order of one person looking at platform stuff full-time for every 10 to 20 engineers you have building components on top of it. And I suspect that if you stray far away from that ratio, you may well end up missing opportunities or economies that come from having a focus on a shared platform layer. Right, so now you know why we have a platform and how it works. So I'd like to share some of the lessons we've learned building and running it. And we've found that as platform owners, we spend a lot of our time weighing the pros and cons of consistency versus flexibility. Whenever we consider a change to the platform, we want to be sure that it leaves enough flexibility for service owners to innovate and use the right tools for the job. But we also want to encourage consistency to prevent people from having to reinvent the wheel or to stray away too far away from best practices. So with that in mind, I've split the lessons learned into 2 sections. Firstly, the areas where we've found it to be better to encourage consistency. And then secondly, after that, I'll talk about the areas where we actually favor flexibility above consistency. So starting with the consistency areas, the first one I've kind of touched on already. It's about logging. So we found it to be very, very valuable indeed to force all services to use the same logging and monitoring infrastructure. Apart from anything else, this means you can correlate that data across services, which is great. But it also means that when engineers move between services, you get some nice economies because they already know all of the peripheral tooling that they need in order to operate those other services. Another neat thing about logging is that we very strongly encourage developers to log structured data rather than just plain text. So for example, this is what an access log might look like as structured data. You can see it's JSON, there's a field for the method, there's some fields for the headers. The reason we do this is because that structure can be understood and indexed in near real time by Elasticsearch. So then developers can build really elaborate dashboards that understand that structure, that query across the data, so they can mine it, but graph the numbers and so on. So we get a lot of value from doing this. The next area where we like consistency is around upgrades. So as a rule of thumb, consistency is good when risk is high. And for a service, risk is obviously at its highest when you're pushing changes to the service. So we've chosen to enable a small set of deployment patterns, of upgrade patterns, that developers can pick from. And the most common looks like this. So you start off with your service version 1 up and running, so you've got a compute stack and a few backing resources. When the developer comes to deploy version 2, we actually spin up an entire new compute stack with a new load balancer, new EC2 instances, the only difference being that the new instances refer to or suck in version 2 of the service artifact. We then do a health check on that new stack. So it's a mandatory part of the platform contract that every service has to expose a health check URL that the platform can go and query to validate that the stack considers itself healthy. So once we've validated that, and only once we've validated that, do we flip over the DNS so that requests start to come to the new stack. And then we keep the old stack running for a little while so you can roll back if you need to, but eventually that'll go away and you're on version 2. All right. We also like to limit the set of persistent data stores that are available to service owners. And in fact, we restrict it to 3 persistent stores. We have Postgres RDS for relational, DynamoDB for NoSQL, and S3 for object stores. And the reason we do this is because we want to be able to provide really good backup and recovery for all of these persistent stores. So again, you don't need to parse and understand this next slide, but this is what our infrastructure looks like for doing backup, recovery, and replication for DynamoDB. So you can see there's a lot of complexity here. And now if we had to do something equivalent for CouchDB, MongoDB, Cassandra, whatever, NextDB, you can imagine that there would be an explosion of complexity, and it would be very hard for us to commit to providing top-notch backup and recovery. Moving on, so we also like to encourage services to isolate their resources. So by that I mean, if you have Service A and Service B, they'll both come with their own set of resources that will be isolated via AWS security constructs like IAM policies and instance profiles. And then when Service A wants to reach for some data in Service B, what we don't allow is for Service A to go straight to the database of Service B. Instead, we encourage it to go through the APIs exposed by Service B. So the reason for this is to avoid the integration database anti-pattern. So as you know, managing schema upgrades is hard enough when you have one service talking to the database. If you have 5 different services all integrated at the database level and you need to do a schema upgrade, it can become extremely difficult to coordinate that across the services. So by going through that domain logic, you give yourself a level of indirection to be able to be more flexible when it comes to changes at the database layer. All right, moving on. We also find it very valuable to have a common way of storing metadata about services. So this allows us to very quickly find the service owners of any services that use, for example, SQS queues. So we can go and find them if we need to tell them about an improvement or a problem with that flavor of backing resource. This also really helps us with cost allocation. So we have a common mechanism of automatically tagging resources in AWS to do cost attribution to different parts of Atlassian, so that it's not my team that's responsible for paying the AWS bill for all of Atlassian, and we can kind of separate that out nicely. And this is really powerful because it means that when a new dev comes along and wants to deploy a service, they don't have to do any kind of upfront complex procedures to get cost allocated. All of that is handled automatically by the platform. We also restrict SSH access to production nodes. You can't SSH in and go and change stuff on your live production nodes to avoid changes that haven't been through version control and peer review, and to avoid ad hoc fixes that will be lost when the instance is auto-scale or when we recycle the nodes in a deployment. And then relatedly, we strongly favor statelessness. So this is enforced by the platform because if you have a load balancer spraying requests across your nodes, or if you're auto-scaling, adding and removing nodes, you can't rely on state being held onto in memory or on disk within a given compute node. You have to extract that information into a backing store, a persistent store of some kind. So this may all feel like a lot of rules and a lot of complexity, but really it can be boiled down to 2 concepts. The first is 12-factor. So if you haven't heard of the 12-factor app, I strongly recommend going having a read about it. It's a set of 12 design guidelines put together by some engineers at Heroku that are really, really valuable concepts when it comes to building very scalable and operable services. And then the second one is a simile that you may have heard of before. It's the idea of treating your compute nodes as cattle rather than like pets. And the intent here is to have a really well-oiled process to rebuild your compute nodes from scratch. So in other words, the destruction and recreation of your compute nodes is part of your everyday life. So we achieve that because it's part of our deployment process. But there are other ways of doing it, like through Chaos Monkey and that kind of stuff. And so the intent here is to ensure that by having this very well-oiled mechanism of creating your nodes from scratch, you're much more resilient to unexpected failure. So compare that to a case where you've treated your node like a pet and customized it for months and months and years. When that node dies, it's going to be a much more sad event than if you had treated it like cattle. So that's the summary of the areas where we encourage consistency. Let's move on to the areas where we like flexibility. And the first one is about flexibility in terms of technology for the service owner. So we've found nothing turns people away from your platform faster than mandating a particular language or a particular web framework. And so this is the runtimes that we support on our PaaS. And you can see Docker is the most widely adopted. It's also the fastest growing. And of course, in their Docker containers, service owners may be running JVM processes or Node processes or Python. It's entirely up to them. By running in Docker, they get control over the version of the runtime that they're running, so that's an added bonus. But we found that Docker is also a really neat way to enable innovation because there are a lot of very interesting stacks that are running in these Docker images. We have several services that are running Haskell, a growing number of services that are running on Go. So that really enables a lot of flexibility for service owners to use the right tool for the job. Moving on, we also really like it when service owners integrate with third-party hosted services. So this happens very often when there's a gap in the platform and they need to do something that we don't support yet. So for example, we've seen users use Mailgun for outbound email, Cronman for task scheduling, and all sorts of things like that. And this is very valuable to us because it means that we don't block service owners who need that functionality. And they also assess these third-party services. And if they turn out to be really good, then those become the kind of de facto standard that we recommend to everyone who's using the platform to use, rather than us trying to build something equivalent. Another interesting one, so we have to be very flexible when it comes to adapting to problems in the underlying platform. So remember, it's platforms all the way down. Our platform runs on top of AWS, and every so often we run into unexpected limitations in AWS, so things like resource count limits, API throttling, that kind of stuff. So when this happens, we have to react and work around those problems. There's actually a team at Atlassian that's built a tool that runs on top of Micros that monitors all of our AWS accounts for known limits and automatically raises support cases with Amazon when we get close to them, because many of those limits are actually soft limits that can be bumped up by Amazon. So that's pretty neat. All right, education. This is my favorite one. So we're very flexible when it comes to providing training to other teams in terms of using our platform. So we have a few tools on this front. We do something called a boot camp, which is a 90-minute workshop that pretty much every new engineer goes through. Probably about 300 people have been through it so far. And the commitment we make is that by the end of that boot camp, they will have deployed a service to the platform. So it's a really nice way of getting the platform in everyone's mind so that when they go and start on their projects, they know that it's there and they know it's something they can use. We also do a number of rotations. So we rotate people from the platform team onto service teams so that everyone gets an experience of seeing the platform from both sides. We have a rotation within the team called Developer on Support, where their first focus is handling support requests and help requests from the rest of the organization. And we also do kind of bespoke training for teams, for entire teams who are using the platform for the first time and have a particular use case in mind. So all of that is really valuable for building a kind of internal developer community around the platform. We're also very open to getting contributions to the platform from other teams. And the interesting thing here is that a lot of the components that constitute Micros run on Micros, so it's kind of self-hosting. And this means that people who build services on top of the platform inherently already know how to contribute to it. So for example, there was one team that was building a lot of services, and they got tired of some of the boilerplate they had to do when they were creating new services. So they built a web UI that allows you to select from a number of service templates, press a button, and that would automatically go and create your Bitbucket repository, create your build plans, and deploy your skeleton version of the application. So you just have to go and fill in the gaps to get your service running. And lots of people started using that, so that effectively became a part of the service, a part of the platform, rather, sorry. And I won't go through all of the details, but this keeps happening. We keep getting developers who build tools that run on the platform that are valuable to the rest of the users of the platform. So in a sense, the platform keeps growing with these contributions, and it's a really, really useful thing. And the last point that I'd like to make about being flexible is about your roadmap. So you'll get a lot of requests from everyone using the platform, if you're a platform owner, about new features that they want or changes that they want in the platform. One way to handle that is with those rotations where you have engineers from service teams coming onto your platform team to help do those things. But in addition to that, as a platform owner, you'll very often be on the hook for organization-wide drivers, so things like organization-wide disaster recovery policies. There will usually be work for the platform owner on that front, and compliance as well, so things like SOC, SOC 2. The platform owner will very often be on the hook for changes around that kind of stuff. And then while you're doing all of that, you also need to keep some roadmap room for upcoming technologies that will represent significant opportunities for your infrastructure. And two of those that we're really excited about are container clusters, so things like Kubernetes and Mesosphere. Those look like they're going to provide some really nice efficiencies in terms of multiplexing services across virtual machines and providing more elaborate orchestration constructs. And then serverless, I'm really excited about serverless because it seems like a very interesting way to enforce some of the 12-factor concepts of statelessness and isolation to kind of guarantee horizontal scalability. And in fact, the next talk on this track after lunch is about serverless, so I very much recommend sticking around for that one. All right, so as you walk this kind of tightrope between consistency and flexibility, it's important to keep in mind that the role of your platform is to try and deliver on many of these promises that come with service decomposition. So this includes things like resilience and scalability, which we achieve through AWS constructs like availability zones and auto-scaling groups, but also through best practices like 12-factor. Also, you've got to enable your teams to deploy independently. So we achieve that by giving them the tools that they need to deploy safely without any inherent kind of blocking points on other teams. You want to let your teams have choice of technology, and we achieve that primarily through Docker. And then you want to ensure that service owners feel end-to-end ownership for their service. And we achieve that by also giving them the tools to deploy safely, and then having the tools to monitor and follow their service well after it's gone into production. So, to wrap up, if you're heading in the microservices direction, remember that your choice of platform is going to be key to your success in this new world, because it determines the overhead of creating and running new services. So a key question that always crops up when people work with microservices is what is the right size for a service? When should I take a big service and split it up into smaller chunks? And it's never going to be the right time if you don't have a good platform to help you. So my final tips to set off in the right direction are: remember to always balance consistency with flexibility. You want to be flexible enough to enable innovation, but consistent enough to add value in terms of resilience and best practices. And when you're making these decisions between consistency and flexibility, you can use concepts like 12-factor and nodes as cattle as your kind of technical guiding directions to help you find the right balancing point. And then lastly, make sure you keep your platform's barrier to entry very low, because your platform isn't going to be worth much if nobody's using it. And the best way to ensure that people do is to support service owners from spike all the way through to production. So thank you very much. I'll be around over lunch for questions. Thank you.